Our next module is Hadoop. So what is Hadoop? Hadoop is a free Java-based programming framework that supports the processing of large data set in a distributed computing environment. It is a part of Apache project sponsored by the Apache Software Foundation. Hadoop is an open source software framework for storing data and running applications on clusters of commodity hardware. It provides massive storage for any kind of data and numerous processing power and the ability to handle virtually limitless concurrent tasks or the jobs. Let's have a look on the terms which are being used in defining Hadoop. Open source software. Open source software is created and maintained by a network of developers from around the globe. It's free to download, use and contribute to, though more and more commercial versions of Hadoop are becoming available today. Framework. In this case, it means that everything you need to develop and run software application is provided. Programs, connections, etc. everything. Massive storage. The Hadoop framework breaks big data into blocks, which are stored on clusters of commodity hardware. Processing power. Hadoop concurrently processes large amount of data using multiple low-cost computers for fast results. Hadoop makes it possible to run application on system with thousands of nodes involving thousands of terabytes. Its distributed file system facilitates rapid data transfer rates among nodes and allows system to continue operating uninterrupted in case of a node failure. This approach lowers the risk of castrographic system failure even if a significant number of nodes become inoperative. Hadoop was inspired by the Google's MapReduce, a software framework in which an application is broken down into numerous small parts. Any of these parts can run on any node in the cluster. Door cutting. Hadoop's creator named the framework after his child-stuffed toy elephant. The current Apache Hadoop ecosystem consists of Hadoop kernel, MapReduce, the Hadoop distributed file system that is HDFS, and a number of related projects such as Apache Hive, HBase, and Zookeeper. The Hadoop framework is used by the major players of the industry such as Google, Yahoo, and IBM, largely for applications involving search engines and advertising. The preferred operating system are Windows, Linux, but Hadoop can also work with BSDs and OS X as well. Big data storage. Hadoop is highly scalable analytics platform for processing large volume of structured and unstructured data. By large scale, we mean multiple petabytes of data spread across hundreds or thousands of physical storage servers or nodes. Hadoop was developed in 2005 and now an open source platform managed under the Apache Software Foundation uses a concept known as MapReduce that is composed of two separate functions. The map sets input data and breaks it down for processing across node within a Hadoop instance. These worker nodes may in turn break the data further for processing. In the reduce step, the processed data is then collected back together and assembled into a format based on the original query being performed. To cope up with the truly massive scale data analysis, Hadoop developers implemented a scale-out architecture based on many low-cost physical servers with distributed processing of data queries during the map operation. Their logic was to enable a Hadoop system capable of processing many parts of a query in parallel to reduce execution time as much as possible. This can be contrasted with the legacy structured database design that looks to scale up with a single server by using faster processing, more memory, and the fast shared storage. Looking at the storage layer, the design aim for Hadoop is to execute the distributed processing with the minimum latency possible. This is achieved by executing map processing on the node that stores the data, a concept known as data locality. As a result, Hadoop implementation can use SATA drivers directly connected to the server, thereby keeping the overall cost of the system as low as possible. To implement the data storage layer, Hadoop uses a feature known as HDFS or the Hadoop Distributed File System. HDFS is not a file in the traditional sense and isn't usually distributed mounted for a user to view, which can sometimes make the concept difficult to understand. It perhaps better to think of simply as Hadoop data store. HDFS instances are divided into two components. The name node, which maintains metadata to track the placement of physical data across the Hadoop instance, and data nodes, which actually store the data. You can run multiple logic data nodes on a single server, but a typical implementation will run only one per server across an instance. Only one per server across an instance. So what are the challenges of using Hadoop? MapReducing programming is not a good match for all the problems. It's good for simple information requests and problems that can be divided into independent units, but it's not efficient for iterative and interactive analytics tasks. MapReduce is file intensive. Because the node doesn't intercommunicate, expect through sorts and shuffles. Interactive algorithms require multiple map shuffle phases to complete. This creates multiple files between MapReduce phases and is inefficient for advanced analytic computing. Another challenge we have is a widely acknowledged talent gap. It can be difficult to find the entry-level programmers who have sufficient Java skills to be productive with MapReduce. That's one reason distribution providers are racing to put relational technology on the top of Hadoop. It is much easier to find programmers with SQL skills than the MapReduce skill. And the Hadoop administration seems part art and part science, requiring low-level language of operating system hardware and Hadoop kernel setting. Data security. Another challenge centers around the fragmenting data security issues, though new tools and technologies are surfacing. The Kerberos authentication protocols is a great step toward making the Hadoop environment more secure. Another challenge for Hadoop is full-fledged data management and the governance. Hadoop does not have easy-to-use full-feature tools for the data management, data cleansing, governance, and the metadata, especially lacking other tools for data quality and standardization. So what are the steps of getting the data into the Hadoop? So this is the way how to get your data into the Hadoop. Let's have a closer look at this. Load files into the system using simple Java commands. HDFS takes care of making multiple copies of data blocks and distributing them across multiple nodes. If you have a large number of files, a shell script that runs multiple put commands in parallel will speed up the process. You don't have to write the MapReduce code. Create a cron job to scan a directory for new files and put them in HDFS as they show up. This is useful for things like downloading email at regular intervals. Mount HDFS as a file system and copy or write files there. Use Scoop to import structured data from relational database to HDFS, Hive and HBase. It can also extract data from Hadoop and export it to the relational database and data warehouses. Use Flume to continuously load data from logs into Hadoop. Use third-party vendor connectors like SAS or SAS data loader for Hadoop. So these are the steps for getting the data into the Hadoop. But why Hadoop? Apache Hadoop enables big data applications for both operations and analytics and is one of the fastest growing technologies providing competitive advantage for business across the industries. Hadoop is a key component of the next generation data architecture, providing a massively scalable distributed storage and the processing system. Hadoop enables organizations to build new data-driven applications while freeing up from resources from existing systems. MapR is a production-ready distribution for Apache Hadoop. What are the benefits of Hadoop? Hadoop helps in changing the economics of data. With the emergence of Hadoop, CIOs are rethinking their enterprise data architecture. Data, which was previously too expensive to store, can now be made available for analysis to improve business insights. Hadoop also enables the capturing and storing of data from every touch point in an organization while eliminating separate silos to process their data. Another benefit of Hadoop is more data leads to better insight. Users across industries are now able to bring structured, unstructured and semi-structured data sources together on one platform to perform deeper and more accurate analysis for improved customer interactions and day-to-day operations. Examples include here building customers 360-degree view of both transactions and interactions, measuring brand health across channel, improving real-time fleet logistics, improving risk modeling and fraud detection algorithms, and also improving the quality control on assembly lines. One of the most common insight across these customer experiences is that expanding the data for a given model can have dramatic improvement in analysis, game-changing business application. In addition to data management and analytical applications powered by Hadoop, more organizations are powering business-critical operational applications where low latency and transactional consistency are important. A large number of Web 2.0 companies are providing Hadoop-based services such as advertisement auction engines, product search, and family history services, while large enterprises are leveraging search and NoSQL database on Hadoop in order to create data-driven services for their customer. Examples include real-time product offering for the customers, power grid optimization, and cable advertising optimizing using setup box tool. Another benefit for Hadoop is transforming business across industries. Every industry is benefiting from the scale and processing power that Hadoop brings, becoming more data driven and gaining deeper insights to customer and operations. And thus, we can conclude Hadoop is a game changer.